So what what it means for anonymized to be on chain is, for example, like if you actually go to any smart contract right now that's an ERC 721 smart contract, and you go to the contracts tab, you can actually see a function that you can call um, that says token URI, which will return to you the actual token URI of the metadata for that specific token. Um, so for non-on-chain art, what typically happens is you mint the token, and once the token is minted, a separate function will say, set this token's URI to API.com or privateserver.com. And that's how each token points to its respective metadata, because there's actually something setting the token's URI to a specific URL. And
Interesting.
URI and URL, they're interchangeable in this context. But for anonymize, every time an anonymize is minted, rather than anonymized token number one pointing to anonymized.com, like setting the token URI to be a current private URL, what is happening is when you mint an anonymize in the contract itself, like this is public, so you can actually go to the anonymized contract and see how it's making the art. But in the contract itself, in the mint function, it's actually setting bit number one needs to be blue, bit number two needs to be black. And it's actually making the images and putting the colors for the mice as something called an SVG, XML SVG. So in the contract itself, it's constructing that image using colors and bits and bytes. And then once that mouse is generated, it encodes the actual image as base 64, and then says token one equals the base 64 encoding, rather than token one equals API.com. If that makes sense, it's very technical, but
And is that publicly on the ERC 127 that you mentioned earlier? Is that all on, it's all public?
yes, like you can see exactly what Anonymize is doing right now. So I can I'll just send you the contract if you were curious of taking a look at it. But yeah, all these contracts are open source, so you can see exactly like how the anonymized are being generated, how they're being stored on chain.
And then
Um,
with the contracts, like is how big are like these contracts? Are there like 1 kilobyte, 1 megabyte? And is there's like thousands of Ethereum contracts. Are all these contracts somehow stored on how do you store that on Ethereum? If there's like and then is everyone that's trying to help mine Ethereum, are they sort of all like partially owning different contracts so like you can verify things? How does that work?
um, so your first question was how big are these contracts? Um, I don't actually know like the physical like size of how many bytes it takes to store these contracts. I'm sure I can search it up right now. How big is an ERC 721 contract? Like you don't really have to think of stuff like this, especially on one sec. How big is it? Bytes? Okay, okay, it's not common knowledge, but essentially when you're making a contract like this, especially an NFT contract, which a lot of them are just kind of similar because all of them inherit from the standard ERC 721, which is like made by Open Zeppelin. We don't really think about like how big is my contract. Like that does play a factor in how much gas it costs to put onto Ethereum. Um, Actually, like, yeah, let me go back. Okay, it doesn't matter how big your contract is. So if you want your contract to be as cheap as possible to deploy, you want to think about how to make your contract, I guess, quote unquote, smaller. Like, how do I eliminate transactions? How do I eliminate computations that I need to do on Ethereum to get my contract out and for the mint to happen? So, for example, if I have a contract that does um, a lot of computation, like in a loop, I loop like 10 like every minute I loop 10 times and change 10 pieces of data in my smart contract, that will be more expensive than if in my contract, I didn't have a loop and I only changed one piece of data, because Ethereum charges you per computation. So for example, like if you're adding a number together, that costs, if you're adding a number and saving it to a variable, that costs, I don't know, like 4 way. If you're doing a multiplication, it costs you this much way. And all those add up. So if one mint does an addition, a multiplication, a subtraction, and division, and all that stuff, it will cost you this much gas to do these transactions. I mean, to do these computations at a bare minimum. And then you factor in gas costs and stuff like that. So inefficient contracts, which do more computation, will cost more to execute versus a well implemented contract. So that's why when you mint an NFT, it's more expensive than when you're just trying to send an ERC20 token to someone else, to another wallet, because there's different computations that goes into minting an NFT versus sending and transferring regular tokens.